In this lecture, we will study Green's reciprocity theorem. This theorem is very useful, especially when we have different conductors and different potentials. We can use this theorem to make our life easy. So let us see what is this theorem. Let us say there are n charges. So I bring Q1 charge from infinity, and let us say Q2 dash, Q3 dash, Qn dash charges are already there. So the work done to bring this charge at point 1 will be where V1 dash is the potential due to all other charges at point 1. So I can write it as Q1 Q2 dash 4 pi epsilon naught R12 Q1 Q3 dash 4 pi epsilon naught R13, so on Q1 Qn dash 4 pi epsilon naught R1n. Similarly, if I bring charge Q2 at its place, I can write Q2 Q1 dash 4 pi epsilon naught R12 plus, you see, when there is just one charge, let us say Q1, I can take it anywhere because the charge do not create a force on itself. So the work done to move this charge without any other charge or any field, there is no energy consumed, because if charge cannot exert force on itself, that's why I am putting 0 in these places. Q2 Q3 dash 4 pi epsilon naught R23 Q2 Qn dash 4 pi epsilon naught R2n. Similarly, if I take this up to nth charge, I can write Qn Q1 dash 4 pi epsilon naught R1n plus 0. Now let us add these columns. So on adding, what I will have Q1 V1 dash, Q2 V2 dash up to Qn Vn dash, and the first column sum will give me 0 plus Q1 dash, I will take common from everything, Q2 over 4 pi epsilon naught R12 up to Qn over 4 pi epsilon naught R1n. Similarly, from the second column I can take Q2 dash common, it will be Q1 over 4 pi epsilon naught R21 plus Q3 4 pi epsilon naught R23, so on to Qn. So this is Qk Vk dash, where k is from 1 to n, and this is equal to, now this thing is equal to Q1 dash into the potential at point 1 because of all other charges. Similarly, this is equal to Q2 dash into potential due to all other charges at point 2 up to n, I can write. So you see, in summation form I can write it as Qk Vk dash from k is equal to 1 to n is equal to Qk dash Vk, where k is equal to 1 to n. So what does it mean? It means that a configuration of various conductors having some charge Q1, Q2 or potentials V1, V2 something, we can either take some charges and corresponding potentials, or we can take corresponding potentials and charges. Their sum should be equal. So let us try to use this theorem and implement this so that we can understand what is the meaning of this theorem. So let us say there is a conducting sphere. Let us say it is given charge Q, and it is grounded. Its radius is a. Now we are told that there is a charge Q at a distance f from the center of this conducting sphere. Now we want to see what can be the equivalent charge for this system of this conducting sphere. So we will take one scenario. So we will make a table. this is QV, this is Q dash V dash. This is for point charge. Let us say I will call it as C. This is for point charge and this is for conducting sphere. So when there is this point charge Q at C, I don't know the potential at this point. Similarly, I don't know what will be the charge induced because of this point charge in front of this conducting sphere. So I don't know the charge here, but I know the potential because it is grounded. It is given that this conducting sphere is grounded and the point charge Q is placed at distance f from the center of this conducting sphere. So I just earnestly mentioned this Q, forget about it. Now what I will take another case where I will assume that there is no point charge here, but there is some charge Q on this sphere. So this is charge Q on this sphere. Now there is no point charge here. Now we know that the potential will be simply, because this is just an isolated sphere now, conducting sphere with charge Q, so charge will uniformly spread over it, so it will be Q by 4 pi epsilon naught F. Now similarly the potential of this sphere will be Q by 4 pi epsilon naught A. In this case we could not know because the density of charge will be different, because plus minus Q charge, minus charge will be here if it is plus, and plus charge will be here. So this distribution of charge is not uniform, but here, because it is since now isolated and there is no charge here, so this Q charge will uniformly spread over it. So these are the two cases we have taken. Now we will use QK VK dash is equal to QK dash VK, that is Green's reciprocity theorem. So Q into 0, that is this combination, this combination Q into Q by 4 pi epsilon naught F plus this into this. Now this Q induced I don't know, we have to find, into Q by 4 pi epsilon naught A should be equal to this into this. So this into 0 will give me 0. Similarly this into this will give me 0. So it implies Q by 4 pi epsilon naught F is equal to minus Q induced Q over 4 pi epsilon naught A. So this will get cancelled out, this will get cancelled out. It implies Q induced is equal to minus Q over A by F. So this is the equivalent induced charge on the conducting sphere. Now when we will study the method of images, we will find that this is actually the equivalent image charge, which we will have to put somewhere here, where this distance will be A square by F and it will be minus A by F cube. So now we can solve this problem by just removing this sphere and just two equivalent point charges here. So in this way we can solve the problem. So from Green's reciprocity theorem we directly found the equivalent induced charge or the image charge. Now we will solve a very good example to again see how to utilize this Green's reciprocity theorem for calculating various capacitance also. So what are we given? We are given that there is a conducting ring and its radius is A, and it is given that when there is a point, this conducting ring is grounded. It is given that when there is a point charge Q here, which is at distance B from the center of this ring, the charge induced in this ring is minus Q. Now we have to show that the capacitance of this ring, isolated ring, is 4 pi epsilon naught Q inverse A square plus B square. We have to show this thing. Now how to do it? So again we will make a table. QV, Q dash, V dash. This is for the point charge, let us say this point charge at C, and this is for ring. So when there is this point charge Q is there, now we don't know the potential of the point charge. because at this point, if the self potential is considered, we don't know what it is. Similarly, this is minus q, but we are told that it is grounded. Now we will take a scenario when this charge q is not present. So this charge q is not present, and this is a. Now we will think that we are going to give this ring as q dash charge. Now we know that if this ring is given q dash charge and it is isolated, there is no nearby charge, then this charge will uniformly spread, and lambda, the charge density, will be q dash over 2 pi a. Okay, or we can see that the potential at this point p, a square plus b square under root. The potential at this point p c will be, v at c will be lambda d at x or dl 4 pi epsilon naught a square plus b square under root. Now vc will be equal to lambda into 2 pi a, or this will give you total charge q dash over 4 pi epsilon naught a square plus b square under root. So if I give this q dash charge and there is no charge here, then I know that the potential is q dash over 4 pi epsilon naught a square plus b square, but here I don't know the potential as of now. So now we want to calculate the capacitance. So first we will use Green's theorem again. Qk Vk dash is equal to Qk dash Vk. So this into this, Q into Q dash 4 pi epsilon naught a square plus b square, and this into this voltage I don't know, minus Q into V ring dash is equal to this into 0 is equal to 0, this into 0 is equal to 0. So we see that Q dash 4 pi epsilon naught a square plus b square is equal to Q into V ring over just V ring. Now on solving this, we can find V ring now. V ring dash is equal to Q over Q 4 pi epsilon naught a square plus b square into Q dash. Now we know that the capacitance of this isolated ring is given as the C is equal to the charge when it is isolated and the potential when it is isolated. So Q dash by V dash is equal to Q by Q 4 pi epsilon naught a square plus b square. So you can see that the capacitance of this conducting ring is Q inverse 4 pi epsilon naught a square plus b square, which we wanted to prove. So hence we have proved. So if you find that this lecture is helpful to you, then please share and subscribe our YouTube channel, and also join our Telegram group, whose link is given in the description of this video. Thank you.